So good afternoon, folks. I'm assuming it's afternoon. It could be morning. However, we're going to get started today on a review of the scientific method, looking at some critical vocabulary and concepts that you need to make sure that you are fully comfortable using as we move forward with this new unit that we're starting on the scientific method, and specifically with writing lab reports. So you should have a piece of paper in front of you that says something about the scientific method, and it's got two sides to it, and we're going to start with the side that has blanks to fill in. It has 15 items. So be sure you put your name on that piece of paper. On both sides would be helpful. And then turn to the side that has the 15 questions, and let's get started. So question number 1 says the blank is the part of the experiment that is not being tested and is used for comparison. And the answer to that question is control. C-O-N-T-R-O-L. So be sure to fill that blank in, and I'll give you a couple of seconds to write that down. The answer to the question is control. C-O-N-T-R-O-L. Okay. Question number 2. The blank describes the steps that you use during an experiment. This is called the procedure. There's also another word for it, and that's protocol, which we'll talk about in a little bit. But for this question, you need to write down the word procedure. P-R-O-C-E-D-U-R-E. Give you a couple of seconds to get that. P-R-O-C-E-D-U-R-E. And these are the steps that are written out in very great detail, so that if somebody wants to repeat the experiment that you performed, they have a chance to copy exactly what you did. So it's very critical that this is very precise. All right. The next question, number 3. After an experiment, scientists write a conclusion. C-O-N-C-L-U-S-I-O-N. And this is a section of the experiment or the lab report that summarizes what the experiment results were and discusses. The discussion is in another part, but it sort of just serves as a communication of the final results. So C-O-N-C-L-U-S-I-O-N, conclusion. Question number 4. 2 words fill in these 2 blanks. The scientific method is a process used by scientists to find answers to questions or to solve a problem. Scientific method is S-C-I-E-N-T-I-F-I-C-M-E-T-H-O-D, scientific method. Hopefully you have that. Let's go to question number 5. Question number 5 has to do with variables. There are a couple of different kinds of variables in an experiment, and this one is the independent variable. So the independent variable is the part of the experiment that is being tested, or the part that's being changed by the person doing the experiment. The independent variable is also sometimes called the manipulated variable, meaning it's the one that's being varied, or the one that's being tested, or the one that's being changed by the person who's working. So independent is I-N-D-E-P-E-N-D-N-E-N-T. Spell that again. I-N-D-E-P-E-N-D-E-N-T. Independent means it's free of all other influences. Let's go to question number 6. Number 6 says the blank is an educated guess, and most people probably by this time know that this word is hypothesis. H-Y-P-O-T-H-E-S-I-S. Hypothesis. That is a pretty common definition for hypothesis. An educated guess. It could also be an assumption that you make about how something's going to turn out based on your own personal history or information that you have researched. and you think that this is the way the experiment is going to turn out. This is done before you ever start so that you're making a basic kind of a wager. I think this is the way it's going to turn out. And so you're then testing it to find out if that's true. Question number 7. Scientists use their data to make charts and graphs. That's the fill in the blank here, graphs, G-R-A-P-H-S, have either bar graphs or circle graphs or line graphs to communicate the results of an experiment. So graphs is the word that makes this sentence complete, G-R-A-P-H-S. Question number 8. After a scientist makes a hypothesis, he or she performs an experiment to collect data. And data is information. We'll talk about that in just a second. E-X-P-E-R-I-M-E-N-T, experiment. A scientist makes a hypothesis and then performs an experiment. Number 9, the first step of the scientific method is usually, because sometimes the scientific method can be tweaked a little bit so that this isn't necessarily the first step. Sometimes the first step is to do research about a problem or a question and then decide what you want to investigate and create the question or the problem that you want to research. So it's usually to identify the problem or the question to be investigated, and you should have both of those words written in. There may not be enough room on the blank. If not, then draw a little arrow down, put one of the words on the blank, and put an arrow down to indicate that the other word works just as well, because you're investigating questions or you're investigating problems when you're working with the scientific method. So Q-U-E-S-T-I-O-N or P-R-O-B-L-E-M, question or problem. Number 10. Number 10 says the lab report also contains information about, and the word here is safety issues that can pose problems. S-A-F-E-T-Y. So remember I told you that Benjamin Franklin recorded his or wrote down his experiment about flying kites in a storm, but forgot to mention that you need to use a brass key to conduct electricity down a wire because brass will stop the electricity, and he forgot to mention that. So he did not include safety issues in his lab report. But the word that fills in this blank correctly is safety, S-A-F-E-T-Y. Question number 11. A different variable. The variable that is the part of the experiment that is affected by the independent variable, that is the dependent variable. And sometimes there is more than one dependent variable. So in other words, you get more than one thing affected by the independent variable. Sometimes this is called a responding variable because it's responding to whatever you're doing, right? Whatever you're testing, the response is going to be the dependent variable, D-E-P-E-N-D-E-N-T, dependent. So for example, if you were testing, let's say, watering plants on a schedule, and one set of plants you watered every day and one set of plants you watered every 10 days, the way that the plants would respond to that watering would be an example of dependent variables. All right. Question number 12. After the experiment, scientists organize and analyze the data. So whatever information they have recorded during the time of the experiment that was related to the experiment, not necessarily, I had chicken for dinner that night. That's not important on Thursday when you were taking down the data about your watering plants, but the response of the plants to the water or whatever the experiment is, that data is what you're recording, and after you're finished with your experiment, you organize and analyze, A-N-A-L-Y-Z-E, analyze the data. Question number 13. The information collected during an experiment is called data, D-A-T-A. An interesting thing that most people don't know about this word is data. The word data is plural. So if you have one piece of information, that is not called data. That's called datum, D-A-T-U-M. If you have multiple pieces of information, lots of different points that you've measured, then those points are all referred to as data because it's plural. So D-A-T-A, that's the information that is collected during an experiment. Number 14. Scientists create a set of steps or a procedure or protocol. Protocol is another word that's used sometimes when we talk about experiments and experimental models. In other words, what did you do consistently to collect the same data over and over and over again? So if you were collecting information, let's say about watering the plants, you couldn't do it at different times of the day. You have to do it at the same time every day. If you were looking at how mold is growing on bread, for those of you that were, when we set that up and I had to bring it home, it all molded and I threw it away. But if we were looking at that and taking the data, we would be looking at it every day at the same time, which would have been during your class time, right? So that's part of your protocol or part of your procedure. You need to recognize both of those words. So you put procedure in the question previously. This time you could put the word protocol, P-R-O-T-O-C-O-L, or you could put both procedure and protocol on question number 14. The next one, the last one, question number 15. Similar to a list of ingredients for a recipe, a lab report also contains a list of materials. And beyond even just a list of materials, it's just like a recipe in that it tells you exactly how much of each thing that you will need. So if you need 6 test tubes, it's not just going to say test tubes, it's going to say 6 test tubes. If you need 14 liters of water, it's not going to just say some water, it's going to say 14 liters of water. All right? So this is the first side of the page. Now you need to turn the paper over, and we're going to start with filling in the box or the blanks at the top. There are some paragraphs there, and these words that are underlined are going to help you locate where in the paragraph you should put the answers. So the first paragraph says, what is the scientific method? And it says it is a process that is used to find answers to questions about the world around us. So I'm going to give you a few seconds to fill that in. It is a process, P-R-O-C-E-S-S, that is used to find answers, A-N-S-W-E-R-S, to questions about the world around us. If you were to turn your paper over and look back at the definition of the scientific method, you would find that it's very similar on the other side as well. Okay, let's go to the next question. It says, is there only one scientific method? And it says no. There are several versions of the scientific method. Some versions have more steps, while others only have a few. However, they all begin with the identification of a problem or question to be answered based on observations of the world around us and provide an organized method for conducting and analyzing an experiment. So you've got 4 blanks to fill in here. The first one, some versions have more steps. The next one, however, they all begin with the identification of a problem or a question. And the last one, provide an organized method for conducting and analyzing an experiment. So your answers, the first blank is steps, the second blank is problem, the third blank is question, and the last blank is organized. The next one says, what is an hypothesis? It is an educated guess based on observations and your knowledge of the topic. So sometimes, like I said before, on the other side, people don't have a lot of information about something that they might be curious about. So they'll go and do some reading and some research and then decide that something that they've read piques their interest and they want to explore more. And so they will then create a question which they develop a hypothesis for, and then they will develop an experiment to test their hypothesis. So a hypothesis is an educated guess, and the guess can be based on observations that you've made over a period of time or on research that you have done. And finally, what is data? It is information gathered during an experiment. So just one blank to fill in there. It is information gathered during an experiment. So now the next thing that we're going to be looking at are a series of boxes, and there's a blank line at the top of each box. And so there is a phrase that needs to be filled in there. So for the first one, it says, the first step in the scientific method is to identify the problem. What do you want to know or explain? Use observations you have made to write a question that addresses the problem or the topic you want to investigate. So filling in the blank here is identify the problem. So write that on that big long line that's in the top of that box. Identify the problem. So this is, again, the first thing we always do. What is it you want to check out? What is it you'd like to test? What is it you want to know more about? That's going to be your problem. All right, let's go to the next box. The next box, this is the second step. What do you think will happen? Predict the answer to your question or the outcome of the experiment. Form a hypothesis. Form a hypothesis needs to go on that long line in the top of the second box that has these questions in it. What do you think will happen? Predict the answer to your question or the outcome of your experiment. Form a hypothesis. Okay? The next box, the third step in the scientific method, create an experiment. And I left an S off of hypothesis. How will you test your hypothesis? Develop a procedure for a reliable experiment and address the safety rules. So create an experiment is what needs to go on that long line at the top of the third box. Create an experiment. The fourth box, which is the next step in the scientific method, is perform the experiment. So now you've created the steps in your procedure. You need to perform your experiment, record your data as you're doing it, and your data could also include observations. Now there are two kinds of data that you need to be aware of. One kind is called quantifiable data. Okay, quantifiable means you can measure it. So it could be that you're measuring a temperature, or you're measuring a length, or you're measuring a mass, or you're measuring a change in something, but it's something that you can objectively measure. The other kind is called qualitative data, and qualitative means you're describing what happened. The leaves they were white yesterday, they're beginning to turn green today. That's a qualitative statement. That is not something that you're measuring. When you do a qualitative observation, you're describing something that's happening. You're not measuring it, all right? So the fourth box on that long line, it should say perform an experiment. All right, the next box has two different things within it. The first one says, is the data reliable? Does your data and your observations from the experiment support it should say support your hypothesis, but in that long line you should write analyze the data. Okay, so you write analyze the data across that line, and then notice what it says here. At this point, you may have to repeat your experiment because your data is not reliable. In other words, you didn't gather it correctly. It's not conclusive, which means it doesn't prove what you needed it to prove, or it's just goofy, it's nonsense, and it doesn't make any sense at all. So then, if that's the case, you're going to modify your experiment, which means you will rewrite your procedure to address the flaws, and flaws means mistakes in the original experiment, and then yes, you will have to do it over again. So analyze the data goes on the big box, right? On the long line that's in the big box, and then modify the experiment goes in the smaller box that's down below the big box and to the right. So, or the right. Modify the experiment, all right? Hopefully that makes sense. And yes, this is the 5th step in the scientific method. And sometimes you have to go backwards and you repeat the experiment, you gather more data, you analyze that data, and hopefully you corrected the experiment and now you have something that makes sense. All right, and the last box. This is the last step in the scientific method. You communicate the results, which means you're going to write a conclusion that summarizes the important parts of your experiment and your results, your basic results. Okay? It's not a long, drawn-out discussion. It's just simply, I did this and I got this. I did this and I got this. Now, you can add a comment that, and my hypothesis was proven correct, or you could say, my hypothesis wasn't proven. You know, those are also, if your data were gathered correctly, then that means the hypothesis you made was incorrect. And it's okay if you're wrong. It took Thomas Edison, I think well, he didn't do it himself, but he had a whole lot of people working for him. And I think they said it took something like 10,000 different attempts to make a light bulb that would conduct enough light to create a bright light to read by. 10,000. That means there were 10,000 means there were 9,999 things that didn't work before they finally got the one that did. So, you know, they were just retrying and retrying and retrying and redoing the experiment over and over and over and over again. I think I would have gotten tired after about attempt number 4, but, you know, he had a lot of people working for him, so that helped. All right, so this paper that you have just completed today is one that you're going to hang on to and you're going to study, because tomorrow there is a vocabulary quiz or a concept quiz over these particular terms that you just covered, or that we just covered together. So I want to make sure, like I said, that you're good and strong on these before we go on to the next step, which on Wednesday and on Friday we're going to be looking at actual experiments. All right, so you guys have a good evening. Be sure to study. The quiz tomorrow won't take long, and after that you will have an article to read. So if you have any questions, please be sure to put them on the quiz itself. There will be space at the bottom on the back for you to write any questions or comments that you have. I look forward to hearing from you. I look forward to seeing your quiz results, because it's not a difficult quiz. It's just based on the terms.